Team Foundation Server is a Microsoft product which provides source code management, reporting, requirements management, project management, automated builds, lab management, testing and release management capabilities. It covers the entire application lifecycle management. TFS can be used as a backend to numerous integrated development environments but is designed to provide the most benefit by serving as the backend to Microsoft Visual Studio or Eclipse. On-premises versus online, Team Foundation Server is available in two different forms, on-premises and online. The latter one is called Visual Studio Online. Team Foundation Service, see also, Visual Studio Online. Team Foundation Service is a subset of a larger suite, that is called Visual Studio Online. The cloud service offers the most recent features compared to the on-premises version of TFS backed by Microsoft unregistered trademark S Cloud Platform, Windows Azure. For Visual Studio Online, there is no setup required, simply log in using Microsoft account and develop. The main differences at this point between the cloud and on-premises versions of TFS involve customization and extensibility. For example, in the on-premises version, organizations can customize the process templates but in the cloud they cannot. All lab management can be plugged into the on-premises version but there is no lab management for the cloud. Last, two components are not present on the cloud-based version, SQL reporting/BI and the SharePoint. On the other hand, the cloud does have some capabilities, simply because of the nature of the cloud that the on-premises version does not have. These include an automatically scalable build farm and virtually infinitely scalable load testing. And finally, new features come to the cloud every 3 weeks because of the rapid development cycle and these features take longer to migrate to the on-premises version as updates. Architecture, server architecture. Team Foundation Server is built on multi-tier architecture, scalable architecture. The primary structure consists of an application tier responsible for processing logic and which maintains the web application portal. TFS is built using Windows Communication Foundation web services and are available to be consumed by any client. The data tier and application tier can exist on the same machine. To support scalability, the application tier can be load balanced and the data tier can be clustered and if using Microsoft SQL Server 2012, always on SQL Server failover clusters and availability groups are supported which allows for geographic replication of data. The primary container is not TFS, rather it is the project collection. A project collection is a physical database that contains a group of team projects. The project collection is another scalability mechanism in that each collection can be placed on different SQL servers or SQL Server instances. On top of the project collection databases, there is exactly one configuration database per TFS instance which stores metadata regarding the project collection databases. Data from the collection databases is aggregated into the warehouse database which denormalizes the data in preparation for the data being loaded into an analysis services cube. The warehouse and the cube allow complex trend reporting and data analysis. TFS can also integrate with an existing SharePoint farm built out to any scale as well as the built-in Windows SharePoint services. SQL Server reporting services are supported for more advanced reporting against the data warehouse or the analysis services data cube. These installations can be on the same system or on different systems. Build servers, lab management servers, release management servers and proxy servers, test machines and load test machines can also be added to the infrastructure. To support teams requiring enterprise project scheduling, TFS also integrates with Microsoft Project Server which allows enterprise-level portfolio management, resource management and project tracking. Extensibility, Microsoft provides two standalone redistributable APIs for connecting to TFS. One is a native Java SDK, the other is a .NET SDK. These APIs allow for client connectivity to TFS. Because TFS is written on a service-oriented architecture, it can communicate with virtually any tool that can call a web service. Another mechanism is being able to subscribe to system alerts, There are approximately 20 pre-configured alerts, and teams can then add as many other configurations as needed. When used in an extensibility scenario, these alerts can be sent to a web service of your choosing, and then actions can be taken to alter or update the work items. The data warehouse can also be extended through the creation of custom data warehouse adapters. With the introduction of TFS 2012, custom add-ins can also be created for Team Web Access, which are called Web Access Extensions. Clients, in addition to supporting Visual Studio 2010, 2012 and 2013 natively and Eclipse, older versions of Visual Studio and other environments can be plugged into TFS using the Microsoft Source Code Control Integration Provider. These tools provide full access to the features in TFS. Microsoft Excel and Microsoft Project are also supported to help manage work items, which allows for bulk update, bulk entry and bulk export of work items. Microsoft Project can be used to schedule work when conforming to a waterfall software development methodology. Both Excel and Project support bidirectional updates of data. This allows, for example, project managers to put a schedule in Project, have that work imported into TFS where developers update the work, and then the schedule can be updated without the project manager having to perform extra work. For additional information on clients, see OE below. With Team Foundation Server 2012, Microsoft PowerPoint was also integrated with TFS to enable rapid storyboard development to help with the requirements management process. The integration provides extensible storyboard shapes that can be used to build any type of interface mock-up that can then be animated with PowerPoint unregistered trademark S built-in functionality. These storyboards can then be linked to work items. In an effort to handle the growing geographic dispersion of teams and to involve stakeholders earlier and more often in the process, Microsoft added the Feedback Client. This tool allows users to exercise an application, annotate what they are seeing with audio and video, capture screens and provide contextual feedback to the development team. This provides specific feedback on the functionality of an application from a user's unregistered trademark perspective without requiring meetings and demo sessions. TFS also provides for command line tools for both Unix and Windows environments. The power tools for TFS include a Windows shell integration, which allows users to check files in and out, add files and perform other basic tasks by right-clicking on a file or folder. Work items. At the heart of TFS is the a work item. A work item represents a thing. It can be a work that needs to be accomplished, a risk to track, a test case, a bug, or virtually anything else a user can imagine. Work items are defined through the XML documents and are highly extensible. Work items are combined into a process template which contains these and other pieces of information to provide a development framework. TFS includes process templates for the Microsoft Solutions Framework for Agile and CMMI and Scrum. Teams can choose to use a built-in template or one of the many templates available for use created by third parties. Process templates can be customized using the Process Template Editor, which is part of the Power Tools. Work items can be linked to each other using different relationships to create a hierarchical tree of work items or a flat relationship between work items. Work items can also be linked to external artifacts such as web pages, documents on a file share, or documents stored in another repository such as SharePoint. Work items can also be linked to source code, build results, test results and specific versions of items in source control. The flexibility in the work items system allows TFS to play many roles, from requirements management to bug tracking, risk and issue tracking, as well as recording the results of reviews. The extensible linking capabilities ensure that traceability from requirements to source code to test cases and results can be accomplished and reported on for auditing purposes, as well as historical understanding of changes. Source control. Team Foundation Server supports two different types of source control: its original source control engine called Team Foundation Version Control, and with the release of TFS 2013, it supports Git as a core source control repository. Team Foundation Version Control, TFVC is a centralized version control system allowing teams to store any type of artifact within its repository. TFVC supports two different types of workspaces when working with client tools: server workspaces and local workspaces. Server workspaces allow developers to lock files for checkout and provide notification to other developers that files are being edited. A frequent complaint for this model is that files on the development machine are marked as read-only. It also requires developers to go offline when the server can't be contacted. Local workspaces were designed to avoid these problems. In a local workspace scenario, files are not read-only and they do not have to be checked out before working on them. As long as the files are on the developer's local machine, it doesn't matter if the server is connected or not. Conflicts are dealt with at check-in time. To improve performance for remote clients, TFS includes the ability to install proxy servers. Proxy servers allow source control contents to be cached at a site closer to the developers to avoid long network trips and the associated latency. Check-ins are still performed directly against the TFS application tier, so the proxy server is most beneficial in read scenarios. As part of the source control engine, TFS supports a number of features to help developers ensure the code that is checked in follows configurable rules. This rule engine is called a check-in policy. There are several out-of-the-box policies such as the changes at comments policy, which will not allow a check-in unless the developer enters a check-in comment. These policies are extensible and can be used to examine all aspects of the code being checked in, the comments and the related work items. TFS also supports a code analysis feature that when used independently is known as FXCOP. The inclusion in TFS means that the analysis can run against code checked into the server and during automated builds. Git. With the release of TFS 2013, Microsoft added native support for Git. This is not a Microsoft-specific implementation but a standard implementation based on the libgit 2 library. This is the same library that powers the popular GitHub, and the code is freely available from GitHub. Because Microsoft took the approach of using a standard library, any Git client can now be used natively with TFS. This allows tools on any platform and any IDE which support Git to connect to TFS. For example, both Xcode and Android Studio support Git plugins. In addition, if developers do not want to use Microsoft's Team Explorer Everywhere plugin for Eclipse, they can choose to use eGit to connect to TFS. This makes TFS a ubiquitous source control system regardless of the client platform in use. Using Git does not preclude the benefit of using TFS work item or build system. When checking code in with Git, referencing the work item ID in the check-in comment will associate the check-in with the given work item. Likewise, Team Build will also build Git projects. One of the major reasons to use TFS as a Git repository is that it is backed by SQL Server and is afforded the same protection as Team Foundation version control. This gives developers some choices when choosing the type of project and work style that works best for them. At this time, source code cannot be moved from a TFVC repository to a Git repository. However, using the Git TF tool, a Git repo can be moved to a TFVC repository. Reporting has been a core component of TFS since its initial release in 2005. The reporting infrastructure consists of a data warehouse, which is a relational database, and a SQL Server Analysis Services data cube. Both of these sources are available for reporting through SQL Server Reporting Services when this option is installed. Since these are standard database and cube structures, any tool which can point to these data sources can report from them. This includes tools such as Cognos, Tableau, Excel and other reporting tools. Included with each out-of-the-box process template is a set of reports for reporting services which cover build information, test results and progress, project management, agile reports, bug and issue data. New reports can be created using Report Builder for SSRS, and any of the existing reports can be modified. More specialized reporting is available for load test results. This data is available directly within Visual Studio and can be exported to Excel for detailed analysis. TFS 2013 introduced a new feature called lightweight reporting, which provides for the ability to create real-time reports based on query results and which do not rely on the warehouse or cube. TFS 2012 offers real-time burndown, velocity and CFD diagrams directly within Team Web Access. Team Build. Team Build is a build server application included with Team Foundation Server. Two components make up Team Build, Build, which is a declarative XML language similar to Apache Ant and Windows Workflow Foundation. WF was added to the build process starting with TFS 2010, prior to that only Build was available. The build capabilities have continued to evolve with each subsequent release of TFS. In TFS 2010 and 2012, the WF templates files were stored in source control and could be edited and versioned directly from source control. In TFS 2013, these files were removed to eliminate clutter and streamline the build process. The WF templates can still be downloaded, edited and stored in source control if desired, and TFS 2013 does not break existing TFS 2010 or 2012 build process templates. With the support of Git in TFS 2013, Team Build has been enhanced to allow automated building of Git projects as well as TFVC projects. Windows Workflow controls the overall flow of the build process, and TFS includes many pre-built workflow activities for managing common tasks that are performed during a build. Build is the markup language that is found in the proj files. The build system is extensible, with users being able to create their own workflow activities, the ability to inject build into the process and to execute external processes. The workflow nature of the build allows for unlimited flexibility, but it may take some work to achieve that flexibility. Shared and open source projects have been started to build community-backed activities to enhance the capabilities of Team Build. The build process can be configured for various types of builds, including scheduled builds, continuous integration, gated check-in and rolling builds. Gated check-ins are unique to TFS and eliminate the shortcoming of a CI build. In a CI build, if the build breaks, the entire team is blocked from doing a get latest and recompiling. A gated check and build, on the other hand, will shelve code that a developer checks in, perform a get latest on the server code and perform a build. If the build succeeds, the code is checked in on behalf of the developer who submitted the code. If the build fails, the developer is notified and can fix the code before trying another check-in. Builds have retention policies with them so that they do not accumulate when not needed, or build output can be locked and saved forever. New with TFS 2013 is the ability to check in the build results into source control. This was a necessary enhancement to support automated builds on the TFS service where there is no drop location to place the builds. In the on-premises version, build output can be configured to end up in any accessible shared folder location. The build process in TFS is also part of the traceability mechanism, in that build brings together many of the artifacts that are created and stored in TFS. Assuming developers associate source code with work items on check-in, Team Build has the ability to report on the changes in each build, both source code changes and work item changes, as well as test results. As bugs and PBIs are resolved and integrated into builds, the work items which track these artifacts are automatically updated to indicate in which build they were successfully integrated. Combined with the testing tools, testers then get an integrated view of what code was changed in each build, but also which bugs, PBIs and other work changed from build to build. This gives testers the ability to target their testing activities in a more focused manner. Release management. In mid-2013, Microsoft purchased a product called InRelease from Lifecycle Software. InRelease was fully incorporated into Team Foundation Server 2013. This capability complemented the automated build and testing processes by allowing a true continuous deployment solution. The tools were rebranded Release Management for TFS 2013. The release management capabilities give teams the ability to perform a controlled, workflow-driven release to dev, test and production environments, and provides dashboards for monitoring the progress of one or more releases. See also, List of revision control software, Comparison of revision control software, Comparison of issue tracking systems, Microsoft Visual Source Safe, SVNBRIDGE, a Windows client or server-side extension to TFS that allows access to TFS revision-controlled items from Subversion client applications. References. External links: Team Foundation Server, at Work, Visual Studio 2005 Teams System, Enterprise Class Source Control, using Source Code Control and Team Foundation, Team Foundation Server Fundamentals, a look at the capabilities and architecture, Visual Studio Team System 2008 Web Access, Visual Studio Application Lifecycle Management.